Welcome to my channel. Today we are going to discuss about the important questions to be studied for the subject signals and system unit wise. So in the first unit, already you know, the first unit is the classification of signals and system. So in that classification of signals and system, the first topic you have to study the standard signals. Under the standard signals, there are different varieties of signals: step signal, impulse, ramp, rectangular pulse, exponential, and sinusoidal. So there may be a chance to ask that is explain the different standard signals in a 13 mark or 2 mark. So you just draw the particular signal and you have to give the definition for the each thing. Okay, this is the first topic. Then the second topic in first unit is the classification of signal. So under the classification of signal, so there are four different classification is there: periodic, non-periodic, and energy, power, even, odd, and deterministic and random signal. So out of this four topic, this periodic and non-periodic signal, so there may be a chance to ask 8-mark question for two different problem. So that periodic and non-periodic signal may be the continuous time signal or discrete time signal. Okay. Similarly, the another one 8-mark, it may come from the energy and power signal. Okay. That is we have to determine one particular signal x of n or x of t, it will be given in the problem. So you have to classify, you have to determine either the particular signal is an energy signal or power signal. Okay. So this too is a very important 8-mark question. Okay, 8-mark questions in that first unit. Then this even and odd signal, in even and odd signal, there may be a chance to ask either 8-mark or 2-mark question. And this deterministic and random signal, this is only the 2-mark question. Okay, they may be asked what is the comparison or distinguish deterministic and random signal. This is the 2-mark question. And the third topic in that first unit is the classification of system. Okay, so this is the important 13-mark question. Or sometime in part C also this question may come. Okay, so under that classification, so the different classification: linear, non-linear, time variant, invariant, static, dynamic, causal, non-causal, stable, unstable. Okay, so in that the question is that that is some particular problem will be given. So under that problem, you just classify the system is in which category. Okay, this is the one of the important 13-mark question. And the fourth topic, the operations on the signal. So, in that operations on the signal, there may be different operation is there: amplitude scaling, time shifting, time scaling, time inversion, and the combination of time scaling and time shifting, the combination of inversion, scaling, and time shifting. So under that, there may be a chance to ask one 13-mark question. Okay, so in that, so totally this in this first unit, so there may be a chance to ask explain the standard signal one question. And in the classification of signal, periodic, non-periodic problem, energy, power problem, it's a 8-mark, or sometimes they may ask 13-mark question. Then one more question is classification of system, and another one is operations on the signal. Okay, so you see, this is the some example problem for periodic and non-periodic problem. So this is a very important problem. So they given x of t is equal to cos pi t by 3 plus sin pi t by 4. You have to check the signal is a periodic or not. Okay, so this may be a some 8-mark or 4-mark. Similarly, this is also one of the question. And this two problem, it may be a discrete time signal problem under this periodic, non-periodic. Okay, so these are all the some of the important and repeatedly asked question under energy, power, signal. So we have to check the x of t equal to e power minus 2t exponential signal. This is the energy or power. Or x of t equal to a rect of t by t naught, rectangular pulse. It is the energy or power. Or a sin omega naught t, or a cos omega naught t. Then phi cos 17 pi t plus pi by 4 plus 2 sin 19 pi t plus pi by 3. So these are all the repeatedly asked the question in the previous years. Okay, so these are all the discrete time signal under this energy, power. x of n equal to 1 by to the power n u of n, or a power n u of n, or simply u of n, or r of n. Okay, so already we solved these problems in our video. If you want to learn those videos, I will give the link for that video in the description box. You can refer it. Okay. Then this is the class. This is that is operations on the signal under the problem. So there may be given some x of n, the signal, the discrete signal. There may be given. We have to draw x of minus n minus 1, x of minus n by 2, minus 2n plus 1. That's all. Okay. This is one of the 13-mark question. Okay, so this is the classification of system problem. So in the classification of system problem, for example, you see, check whether the following systems are linear, causal, time invariant, static, stable or not. Okay, so y of n equal to this, y of t equal to 10 sine 10 x of t plus 6, y of t equal to x of 2t, y of n equal to cos x of n. These are all the some sample problems related to this classification of signal. Okay, so that's all the first unit. And you see the second unit. In second unit, there may be three different subtopic is there. One is Fourier transform, and another one is a Laplace transform, and the third one is a Fourier series. Okay, so in that the first question, there may be a chance to ask the Fourier transform problem. So in that Fourier transform problem, what are the very repeated and important problem means find the Fourier transform of x of t equal to e power minus 2t u of t, or x of t equal to u of t, or x of t equal to a sin omega naught t u of t, or a cos omega naught t u of t. Then x of t equal to e power minus a t sin omega naught t u of t. Similarly, e power minus at cos omega naught t u of t. So these questions are 8-mark problems. Okay, so the first two, this is the 2-mark problem. This a sin omega naught t e power minus at sin omega naught t. This is the 8-mark problem, very important problem. And another one 13-mark problem in that is find the Fourier transform of this double-sided exponential pulse. That is x of t equal to e power minus a modulus t. This is a very, very important question. So you may solve this question in either Fourier transform or Laplace transform. Okay. Then x of t equal to a rect of t by t naught. These are all the very important questions you have to prepare in it Fourier transform. Okay. Then the another one question, another one chance is to ask the properties of Fourier transform with the proof. Okay. So in second unit and the fourth unit, this properties. Okay, in second unit, Fourier transform properties and Laplace transform properties are very important. Similarly, in fourth unit, is a transform or discrete time Fourier transform problem is very important. So you just study some important properties in that Fourier transform like time scaling, time shifting, then convolution property, convolution in time domain, differentiation property, integration property. So you just prepare some important 5 properties, 5 or 6 properties in Fourier transform as well as the Laplace transform with the proof. Okay. So this is one of the important question in that second unit. Okay. And there may be a chance to, the third topic is a Laplace transform. So in Laplace transform also, this ROC, define ROC in Laplace transform. This is a important 2-mark question. And properties of ROC. This is also a important 2-mark problem. Okay, what is ROC and what are the properties of ROC? It's a 2-mark question. And in Laplace transform also, the same problem. Okay, already we discussed in Fourier transform, the same problem is repeated in Laplace also. Find the Laplace transform of x of t equal to e power minus a t u of t, or simply u of t, or a sin omega naught t u of t, a cos omega naught t u of t, e power minus a t sin omega naught t. Then similarly, e power minus a t, a cos omega naught t u of t, and x of t equal to a rect of t by t naught. So the same problem is repeated in Fourier transform as well as the Laplace transform. Okay. And one more problem in this Laplace transform is obtain the Laplace transform of the double-sided exponential signal x of t equal to e power minus b modulus t. Okay, this is a very important 13 mark question. Okay, and if it is a Fourier transform, after finding the Fourier transform, we have to draw the spectrum. And in this lap, if it is a Laplace transform question, we have to find the ROC. We have to draw the ROC. Okay, this is a very important problem in either Fourier transform or Laplace transform. We may expect one 13 mark question from this. Okay, and the fourth topic in the second unit is the inverse Laplace transform problem. So there may be a chance to ask the inverse Laplace transform problem. Okay, find the inverse Laplace transform of x of s equal to some 2 by s square plus 3s plus 2, like that. Okay, this is also one of the question. Okay, and in that second unit, the third topic is a Fourier series. Okay, so already the in second unit there are three topics there: Fourier series, Fourier transform, Laplace transform for the signals. Okay, so under Fourier series, there are 7 problems there, but this is the very important and repeatedly asked question. Find the Fourier series representation of rectangular pulse train, half wave rectified signal, full wave rectified signal, and triangular waveform. Okay, so you just prepare these questions. Okay, so that's all the second unit. And the third unit, the third unit is an analysis of LTI, continuous time system, using the Fourier transform and Laplace transform. Okay, so this third unit is a very important and easy question, easy unit in order to solve the problem. And the first question is, so you see, this is the analysis of LTI system using Laplace transform. So you see, this such questions you may receive. That is, some differential equation representation of the system is given. dy of t divided by dt plus 2y of t equal to x of t, and find the response. Response means the output produced by the system. We have to find out for the given input x of t equal to e power minus 3t u of t. Okay, so the same problem you may solve it in Fourier transform also. So sometime in that question itself, they mentioned using LT. LT means Laplace transform. We have to solve this problem, means you just use Laplace transform in order to solve this problem. Okay, the same question they asked in Fourier transform, means you just apply the Fourier transform in order to solve this problem. Okay, so this type of questions you may receive. Okay, this is the one problem. And you see, the differential equation is given. In that, you just find the transfer function h of s and output y of t for the particular input. Okay, this is also one of the question. And one more question is, we have to find for the same differential equation, we have to find the frequency response h of j omega, and we have to find the output for the particular input. Okay, so this, for this type of question you may choose the Fourier transform, since the question is we have to find the frequency response. Frequency response means h of j omega. So h of j omega, in order to find out the h of j omega, we must use the Fourier transform. Okay, so this is the one type of problem. And the second topic you have to study in that this third unit is a convolution integral problem. Okay, so already know the convolution integral is used to calculate the output of the system, output of the continuous time system, if the input and impulse response is given. Okay, so you see one of the sample problem: perform the convolution of the following: x of t equal to u of t, h of t equal to u of t. So here x of t is the input, h of t is the impulse response. So if input and impulse response is given, means if you are performing the convolution between these two signals, we will get the output of the particular system y of t. Okay. Or one more thing, x of t equal to e power minus 3t u of t, h of t equal to u of t plus 3. Okay. So this is also one of the convolution problems. So you may receive, you may get one problem from this convolution integral using graphical method. Okay. And another topic in the third unit is systems connected in series and parallel. Okay. So from this topic, you may receive some of the important 2-mark questions also, as well as big questions also. Okay. So you see, there are two types of system connection is there. In that first diagram, the two systems two or more systems that are connected in series. Okay, if the two systems are connected in series means the overall impulse response is nothing but the convolution between the individual impulse responses. Okay, this connection is equivalent to this connection. Okay, similarly, if the two or more systems are connected in parallel, okay, this connection is said to be parallel. In that thing, this diagram is equivalent to, it is the addition of individual impulse responses. The overall impulse response is nothing but addition of individual impulse responses. So using this type, you may receive some of the big questions also, or two more problem, or 2 mark definition also you may get. Okay, this is the one question. And another one topic is the conditions for causality and stability. Okay, so this causality and stability condition is a very important 2 mark in third unit, as well as the same topic is available in fifth unit also. Okay, that is what is condition for causality. The condition in order to check the given system is causal or non-causal. And what is condition for stability means the condition in order to check the given system is stable or not. Okay, so if the impulse response is 0 for the negative value of time means that system is said to be the causal system. Okay, similarly, in order to check the system is stable or not, the integration of the impulse responses less than infinity means that is the condition in order to check the stability. So using this causality and stability, you may get the 2 mark definition questions as well as 2 mark problem. Using this condition, you may solve some system equations may be given. So you have to check the system is either causal or not, stable or not. Okay, so already in our channel, we solved many problems related to this topic. So I will give the link for that signals and system playlist in the description box. You can check it. Okay, then in the fourth unit, so you see the fourth unit is nothing but an analysis of discrete time signal. Okay, so in that fourth unit, so there are three topics there. One is sampling, baseband sampling. The sampling topic is a very important question. Okay, so this is the derivation come theory question. So sampling, the sampling is nothing but the process of converting the continuous time signals into discrete time signal. Okay, so this derivation with a simple derivation with some that is a block diagram and a graphical representation is there for the sampled signal. So you have to just study this question. This is one of the 13-mark question. And the second topic is discrete time Fourier transform. Okay, DTFT. So DTFT is used to solve the discrete time signal. Okay, so in second unit we studied one Fourier transform. It is for the analysis of continuous time signal. Similarly, for discrete time signal, there is a Fourier transform is there. It is said to be the discrete time Fourier transform. Okay, so in that DTFT problem, so these are all the important problem. That is x of n equal to a power n u of n, or there may be instead of this a, there may be 1 by to the power n or 1 by 3 to the power n. This is a very important question in DTFT. Okay, then find the DTFT of the signal x of n equal to u of n, and find the DTFT of x of n equal to a power modulus n. So this is a very important 13-mark question. Okay, so this question is this is the double-sided exponential signal. Okay, in second unit, the two questions we discussed, that is e power minus a modulus t, e power minus a modulus t. Okay, obtain the Fourier transform of this is also a double-sided exponential signal. This is the continuous time double-sided exponential signal. Similarly, in fourth unit, this is the double-sided discrete signal a power modulus n, and draw its spectrum. This is an important 13-mark question. Okay, similarly, x of n equal to a power n u of n plus b power n u of minus n minus 1. Okay, this is an important question, and x of n equal to a power minus n. So these are all the questions from the discrete time Fourier transform. And the next topic is there may be a chance to ask the properties of DTFT and ECE transform. Okay, so already I said in that second unit, In second unit, the properties of Fourier transform and Laplace transform. Okay, in fourth unit, the properties of DTFT or Z transform. Out of this four transform, there may be a chance to ask any one properties with the proof either in second unit or fourth unit. Okay, so you just study some important 6 properties from each transform. And the fourth topic is a transform problem. Okay, so for the same problem we discussed in Fourier transform, the same problem we have to solve it in Z transform also. Find the Z transform of x of n equal to u of n, x of n equal to a power n u of n, x of n equal to a power modulus n. This is the double-sided exponential signal. Okay, and if it is a Z transform problem means they ask draw its ROC. If it is a DTFT problem means draw its spectrum. Okay, this is an important 13-mark question in this is a transform. And similarly, a power n u of n plus b power n u of minus n minus 1 problem. Okay, these are all the is a transform problem. Okay, and there may be another one topic in that fourth unit is a inverse Z transform problem. Okay, the x of z, the capital X of z will be given. We have to convert this Z transform into the corresponding time domain x of n. Okay, so this inverse Z transform problem also they may ask in 8 mark or 13 mark. Okay, that's all in fourth unit. And the fifth unit is a linear analysis of LTI discrete time system. Okay, so in that there are 3 topics there. The first one is convolution sum. In third unit, we discussed, convolution integral. Similarly, in that fifth unit, convolution sum is there. So this convolution sum is used to find the output of the system if input x of n and impulse response h of n will be given. Okay. So you see the find x of n convolution with h of n. The x of n, h of n will be given. So we have to find it. Okay, using the tabulation method you just find the output. Okay, this is a one question. So this question may be 2 mark question or sometime the same question will be asked in 8 mark also. Okay, and the second topic is analysis of LTI system using Z transform. Okay, in third unit we discussed analysis of LTI system using Fourier transform and Laplace transform. Similarly here this is the analysis of discrete time LTI system using Z transform. Okay, so here the system function will be given. So from the system function, so they may ask find the output of the system or step response of the system. Okay, so h of z will be given means using Z transform we have to find the response of the particular system. Then the one more question, a causal discrete time system is described by the difference equation of the system will be given. This difference equation is nothing but the equation in order to describe the system. So from that system, we have to find the system function h of z. And also we have to plot pole zero plot and whether we have to determine the system is stable or not. Okay, so this is under the analysis of system. Okay, and one more topic is analysis of LTI system using DTFT. So in previous topic is analysis of LTI system using Z transform. The same problem we may solve it in DTFT also. Okay, but in that question, if they are mentioning use Z transform, use DTFT means we must use the particular transform. Otherwise, we may use any transform. Okay, so you see one of the problem in this, the input-output relationship of discrete time system given by this difference equation. Find the response. Response means the output. Okay, if the Fourier transform of input x of n is given. Okay, this is the one question. These are all the important university problems. And one more question is the system equation is given. Determine the frequency response h of e power j omega means compulsory we have to use the DTFT, not Z transform. Okay. Then the next topic is the discrete time system contains series and parallel. Okay, the same topic we discussed in third unit, Similarly, in this fifth unit also, discrete time system. In the third unit, the continuous time system contains series and parallel. This is the discrete time system contains series and parallel. If two systems are connected in series means The overall impulse response is nothing but the convolution between the two individual impulse responses. Okay. And if the two systems are connected in parallel means the overall impulse response is a addition of the individual impulse responses. Okay. So from this topic, you may get some 2-mark problem as well as the big question. Okay. 8-mark questions also. And the next topic is the causality condition for the discrete time system and the stability condition for the discrete time system. So this is the condition in order to check the discrete time system is causal or non-causal. Okay. If the impulse response of that particular system is 0 for the negative values of time, that is n less than 0. N less than 0 means for negative values of time, impulse response is 0 means that system is said to be causal, otherwise non-causal. Similarly, the system is the discrete time system is stable or not. In order to check the system is stable or not, the summation, the absolute, that is the particular system h of n, the impulse response, if you are adding the impulse response for the system over the limit n equal to minus infinity to infinity, that impulse response value is less than infinity means that system is said to be stable. Okay, otherwise it's a unstable. So these conditions are very important questions. Okay, in 2-mark question. Okay, so conditions are using this condition we may solve some problems. Okay, so these are all the important questions you have to study in signals and system. If you want to learn all these videos, so already that is all videos are available, all previous 10-12 years questions, Anna University questions already solved in our channel. Okay, I will give link in the description box, you can refer it. Okay, so thank you. We will meet in the next video.